Hello everybody, and welcome to the video tutorial AutoML Frameworks. What we are going to learn on this video tutorial is how to work with automated machine learning frameworks, FLAML and MLJAR supervised. An AutoML framework makes it easier to implement an AI model as it simplifies the workflow of model development for professionals not related to data science field. Let's get started. Step 1. Install the AutoML frameworks and complementary libraries. We should install both FLAML and MLJAR frameworks, aside from other extra packages needed for this tutorial. You should see something like this. And finally, restart the session as suggested by the message right here. Next step, you must download the dataset. The link is provided in the description of this video tutorial. Do this either using Google Drive or Google Colab UI. For this case, we use the built-in Colab module to mount my Google Drive. You must replace the dataset path accordingly. This results in a message like this one, if there is no problems at all. The second paragraph is just meant to confirm the dataset can be read from the notebook. Step 3. Set up the column target and the search time budget. Having uploaded the dataset, we set up right here the column target name. That is the information we want to predict. We also need to set the time budget up during seconds. This parameter is the time of the AutoML framework is going to dedicate to fine-tune the machine learning models until getting the final accuracy. Step 4. Upload data and split. So we require to import pandas and the train test split module to upload and split our data. We go on reading the CSV dataset file, converting it into a data frame. Then we just may separate features on target and split our data into 80% for training and 20% for testing dataset. Right after running the paragraph, you should see that we've got 44 dataset rows with 15 features for training and 12 for testing. Step 5. Run the first AutoML framework, FLAML. We first import the required models of FLAML, as well as other models to calculate the mean absolute error, mean squared error, and R squared. Then we create an instance of FLAML, which we use to feed the models to the training data, features, and target. We also need to add the type of task, a regression. Right here, we set the type of error we want FLAML to use when fitting. This is the search time and a file for saving logs. Next line is meant to test running predict method of FLAML putting as inputs the test sets. And finally, we create a dictionary to save the results. Here we also need to print the results to visualize it. After giving it a shot, FLAML, as an AutoML framework, will take care of finding the best machine learning models with the best hyperparameters for us. So it will iterate over an algorithm and hyperparameter search space until finding the most accurate estimator. We read right here, the best model is the LGMB estimator. Step 6. Run second AutoML framework, MLJAR supervised. Like FLAML, we need to import the corresponding framework model first. In this case, the framework instantiation requires to add the configuration parameters. Search time must be complete, same evaluation metrics, and a validation strategy for the model evaluation during the search. Basically, 25% of the training data sets will be used for the evaluation process. Then we call the fit method of the framework and pass the testing sets as arguments. Predicts, save the results in a dictionary, and print those finally. So after Running the paragraph, we may see the iteration results and the final dictionary right here. But what do the results mean? Let's compare the framework results below. Step 7. Compare AutoML framework results and save artifacts. To compare the results of each framework, we just need to call and print the dictionaries we created above. As an additional step, in case we wanted to save the final models of each framework, we just may run these lines of code. So okay, FLAML and MLJAR. For FLAML, we've got 33% and 30% of errors. For MLJAR, 50% and 45%. Same framework has 78% of R squared and 90% of R squared for FLAML. That means the latter have got a model that best represents the testing data variance. Step 8. Visualize FLAML versus MLJAR results. Again, we use the framework results dictionaries we've created before, and the model pyplot to create charts named as PLT. So, the bar chart titled FLAML versus MLJAR gotten from running the framework results with testing data displays blue and orange bars respectively. FLAML achieves less root mean squared error than MLJAR, same pattern for the mean absolute error. And here, about R squared, FLAML's is taller, thus we may say that the FLAML framework is in this case likely better. However, both got good results. If we pay attention to the next chart built using the same pyplot model, we may see that the prediction versus the real data are quite similar. With the true data along x-axis and the predicted one y-axis, same colors for framework bars and circles right here, the trend is to be linear like the diagonal dashed line. Maybe we find some orange circles like outliers though. Likely that's the reason FLAML got lesser results for this brief experiment. That's all. Thank you for listening.